A lot of news on the moon. 2 moon missions that were launched on the same rocket. Falcon 9 launched 2 of them. One called Blue Ghost, which is by Firefly Aerospace. It's a U.S. small company. And then there's ispace Japan, which is a private Japanese company, although they have a significant presence in Europe and in the United States. So Blue Ghost first. This was under NASA's CLPS program, Commercial Lunar Payload Services. This is the one that a lot of these missions are being funded, or at least partly funded by, where they are acting as kind of the anchor business partner, where they say they want certain things to happen, but they're basically paying for the service to get there, as opposed to buying the rocket and taking responsibility for transportation. They're ultimately trying to have space trucks. The thing weighs a little over 1,000 pounds, including the payloads, not including the fuel. That's called dry mass, which is what it weighs without the fuel. Almost 7 feet tall, almost 12 feet wide, so it's kind of squat. They emphasize that that helps with stability. Things aren't going to tip over so easily, like they did for a couple of previous launches of other landers. It uses a hypergolic propellant. That's pretty normal for something like a long deep space mission where you need to be able to restart under any condition. Hypergolic means you bring, if it's a binary one, you have 2 fuels, they come together and they just automatically ignite without any effort. You don't have a special lighting process or anything. You just bring them together. 400 watts of power. It'll be landing on March 2nd. And it's not worth going through all these details. You can find this stuff on their website. The Firefly website actually goes into great detail on what's there. So if you're wondering what some of this stuff is that you're looking at here, you know, some of it's obvious, like the thrusters at the bottom, the big bell-shaped kind of things. They have to have big nozzles because you're in vacuum. Anyways, they talk about some of the stuff in this picture. I don't think it's worth really going through. I will talk briefly about the orbit. This is very much like what you saw some of the previous landers do, like India's in particular. What you do is you just get up to low Earth orbit on the left-hand side there. That's around Earth. And then every time you're in as close to Earth as possible, you have a burst of power into the engine. That raises your orbit in an elliptical kind of way. The way to think of it is almost like if you're standing in place and you throw something up in the air, it comes back to where you are, but it goes up high and comes back. And it's doing kind of the same thing. All that extra energy really goes into raising the orbit on the other side of the Earth there. And so you do that a bunch of times, and each time the orbit gets bigger and bigger. And then eventually you say, okay, that's it. We got enough velocity. We're heading to the moon. And you go into a translunar orbit, which is something like the 8 and 9 kind of area there.
We're just about at that point.
Yeah, I think that's about where they are right now.
3 more days in Earth orbit.
Yeah. Yeah. One benefit of this approach is if they had some problems along the way, they have time to adjust so they get the maximum daylight time on the moon. Because all these landers are really just mainly designed to last during the lunar day, which is 14 days, Earth days. And some of the experiments are already running. For instance, one of the payloads on this particular mission is some radiation sensors. They're monitoring because they want to know what is the radiation levels all over the place, because it's bad for people and it's bad for equipment. And the only way to find that out is to go there. And so this gives you more data every time you go anywhere in space. If you're taking radiation readings, you learn more. And of course, they're especially interested on land. You know, when you get down to the moon, when you're landed, then, well, what about there? So anyway, that's one mission payload that in fact is already started and probably providing some useful data. This is not worth going into, but for anybody who wants to see the details, how do they actually land, the steps they go through, this is on their website as well. Fundamentally, it's just like bringing the booster back to Earth on one of those Starship things. You turn around, you have a burn to slow yourself down, then they scan the surface and they look for a really flat place, and then they just essentially adjust themselves and finally land. Like most of the others, they don't actually try to land perfectly at 0 velocity. Usually they go for about 1 meter a second, 3 feet a second, and they have good shock absorbing legs. That's part of their design, so they can handle that pretty well. Okay, I'd mentioned briefly the payloads. Again, you can go into detail by looking at their website, but they have some things we mentioned like radiation sensing, various cameras. One interesting test, they're doing some kind of a test on a dust shield, electrostatic dust shield, because dust on the moon is one of the biggest problems to actually being there. Okay, next one, the Lunar Lander by ispace, which is a Japanese company. Not to be confused with I-Space, which is a Chinese company. These people were actually first. There's a smaller, about 750 pounds at landing with all of the experiments on it. They're taking a completely different route to getting there. They're not doing at all what the Indians and the others have done. These are people that failed the last time. And I don't know if you remember why they failed. There's a whole video about that I had done. I'm going into more depth on that. If you're really interested, you You could go look at that. But fundamentally, they only had one altimeter radar. And of course, they're doing checks. One of the typical sensor checks in any system is, well, if you get a sudden change in value, you probably should ignore that because physically you just can't move that fast. But they forgot that if you fly over the edge of a crater, then all of a sudden, like if it's a 5-kilometer deep crater, well, all of a sudden it looks like your altitude just increased by 5 kilometers. And that's exactly what they thought happened. So they said, oh, that reading must not be any good. It actually was good, but they disabled it. The problem was they didn't have any backup sensor. And they're just relying on inertial navigation. It fundamentally just slowly kept coming down, thinking it was almost landing, when actually it was 5 kilometers above the crater floor. So it was up that high, and then it just gradually was coming down slower and slower, thinking it was getting closer and closer to the ground when it was nowhere near. It just ran out of fuel, and then at that point it fell and crashed. So that was the failure. So they've said they fixed that, but they keep referring to it as a software bug, and it wasn't a software bug. It was a failure to think through the different failures that could happen. And so I don't know if they actually added additional sensors or not. Nobody's said anything about that. Part of the reason they had this problem was they changed the destination at the last minute on the first mission. They weren't going to land in a crater the first time. And then, so they changed it, but they didn't test it. Even in software, they didn't go through and just simulate what would happen, if you landed at the new location. And sure enough, it crashed. So I think they're landing in a big flat area that doesn't really go over a big crater like that. I don't know if they've actually done any other upgrades. The trajectory, as I was saying, is completely different. It's actually built into the kind of a logo. And it wasn't quite sure. It wasn't quite a mission patch, and it's not just a little circular thing with the rabbit ears. But Earth is in the center of that. The yellow orbit there is the moon. And they show way, way past that. At some point, they probably reach a point where either the sun and the Earth or the sun and the moon, gravity is combined because they're lined up. And at that point, they head back with a little extra gravity pull. As a result, they don't need much fuel to do any of this kind of stuff. They've never published much in the way of details. And I think Mission 2, they changed it slightly because I saw one picture and there's one extra lunar flyby in the thing. So they've done a little bit more. But anyway, there are different ways to go from place A to place B in the universe. And when you're sending a robotic probe, you don't worry about how long it takes. If it takes you 4.5 months instead of a couple of weeks, well, it's no big deal. And that's what they're doing. Payloads, one of which is a rover. That's a picture of the rover there. Their first mission, they had one that was built in the United Arab Emirates by the university there. Well, actually with a lot of help from the University of Colorado. But, it was a joint kind of a project. This one is really their own, designed and built in Luxembourg, of all places. But actually, it turns out they have offices in Luxembourg. Their European offices are there. So this is all part of their efforts. And also, Luxembourg actually wants to be a space power. They're not doing launches and stuff. But they'll do licensing. They're doing a lot of the satellite kind of stuff. They're trying to build up a whole industry there. So they have that. That's the rover. Their emphasis is that it's really, really lightweight. You see those metal wheels with spaces in it and that sort of thing. There's also 3 experiments. One is doing electrolysis of water. We all talk casually that, well, we're going to electrolyze the water there that we find in the ice, and we'll make rocket fuel out of that eventually. Well, it hasn't really been tested on the moon, so they're actually going to do some of that. They're going to do some food production with algae. Deep space radiation monitoring I already mentioned, but there's 2 parts to that. One is the radiation sensor, which everybody does. I mean, everybody tries to monitor radiation. But the other thing is they're doing a much more direct measure of how much will it impact computer equipment. And what they just simply did was they just basically took a whole bunch of memory and they set it all to zeros. And then they just watch and they see, they check like every 15 minutes or on some time period, they check, well, did any of those get flipped? Meaning a cosmic ray hits it, it interferes with it so much it flips the bit from reading 0 to reading 1. And they just count that. It's a simple measure. But on the other hand, other people apparently haven't done that too much.
About how big is this rover?
Maybe 2 feet at most. You can pick it up. I've seen pictures of people walking around just kind of about like that.
Like the space Pomeranian.
There you go. I'm sure. Yeah, you should write them. Maybe they'll maybe they'll change their logo. Now they're also putting down, besides these actual serious experiments, they're putting down a commemorative plaque. Okay, that's fine. And the other interesting one is some Swedish art, and it's specifically called the Moonhouse. And you're thinking, wow, well, why did they pick that? And when you see the picture, what it's going to look like, that's it. It's the little house. Now, and it's actually less than 5 inches wide. You can't judge the scale on this. And you look at that and you go, okay, that's art. 70 people, mostly, I think probably all Swedish, paid the total price, like somehow between $600,000 and $900,000, they raised money to actually pay for this. So it's amazing. People will pay money to do all kinds of things that you might not have thought of in space. And here they're funding, some basic research on how do we get to the moon cheaply by putting that thing on the moon. Apparently, it's a Swedish thing. There's just no other explanation. This similar house has been placed in a space station. I think it was made of cardboard. It was pop-up kind of a thing. It's kind of like there was this old fad in the U.S. for people with kids. They did Flat Stanley. It was just some person. They just basically photobombed every picture of every tourist site they could with that. Well, I think it's kind of like this for the Swedes. This is supposed to represent an earlier, comfortable time for them, a cozy little house. Like, it's a Swedish thing. But it's interesting. I mean, here it's a Japanese company, but they're building the product in Luxembourg, and they're putting art up from Sweden. So this is just more pictures of the venture. One interesting one is, besides all the various payloads we talked about, this thing itself will do a little bit of scooping, and there's a particular reason for that. It's called Venture 4 in this picture. The scoop is here in the front, right-hand side of that one. It'll go down further, and I got a close-up picture of that. You see that on the left-hand side of this picture. It just goes into dirt, and the thing just rolls forward, scoops it up, and then it picks it back up and puts it in there. Why are they doing that? They're selling that to NASA. Why are they selling that to NASA? Well, NASA, the U.S., really wants to establish the Artemis Accords as a legal norm that you can extract resources from the moon. By the Outer Space Treaty, you can't own it. Countries in particular can't own it. But you have rights. We interpret the treaty to say that you can at least extract materials from it and sell it. And that's been done because people have sold some of the lunar rocks and things that were brought back by the Apollo astronauts. There has been some of that. So you could say, okay, the precedent has been set, but this is kind of reinforcing that. Ultimately, if you want private enterprise to start developing space, you need to have a legal framework in place. And this is part of getting to that. It really is independent of whether it's a capitalist society or a social society, because still the question is, if you're China, how much effort are you going to put into going somewhere if you can't actually use the resources? It changes how fast you go into space. So it's a kind of independent of government type, but it is something that the U.S. hopes everybody will agree to. The Chinese will not sign up with the Artemis Accords, but they have actually kind of indicated that this kind of thing, yeah, they support that because they want to go there and extract resources too. One other thing that's interesting is, how does it get from the lander down to the surface? So earlier things you saw in places like Mars, you always had these nice little ramps, everything came down. This thing just has a little arm, it flips out, and then it just drops it because the gravity isn't that high. It just kind of drops down, they show it bouncing a little bit, and that's it. That's probably true for a lot of the payloads they might handle if they remove it from the spacecraft. Okay, that's it. So, right on time. Thank you. Other space-related videos or slide presentations by me are available at the link shown here. That includes a list of videos at my YouTube channel, so you can view them or subscribe for notifications about future videos. These presentations are mostly made as part of the meetings of National Space Society's North Houston chapter, and the link to that is shown. Topics like these are presented as part of a monthly news segment, and there are also lots of other interesting speakers and open discussions. You can attend in person or online via Zoom. Come join us.